The basic components of spacetime are made up of the familiar 3 dimensions of space and 1 dimension of time. We also refer to this spacetime as Lorentzian. Interestingly, it turns out that the dimension of time has some similarities to the other dimensions of space. Time is different from space since it only allows traversal in one direction, forward. However, it can be measured in the same units as space, which is meters. It turns out units of time, like seconds, are just an alternative measurement of the same quantity, meters, with a conversion factor between the two being the constant of the speed of light. So 3.336 nanoseconds of time times c, the constant speed of light, equals 1 meter of time. The constant speed of light turns out to be just a conversion factor to unite the dimension of time with the dimensions of space. Locations in spacetime are called events. An event is necessarily composed of both a component in space as well as time. For example, I throw a baseball. That's an event. The baseball collides with a bat. That's another event. Most importantly, events are part of the absolute reality of spacetime. They occur and all observers agree that they happened and are real. Interestingly, observers in different reference frames will disagree about their measurements of the times and distances between the occurrences of each event. Even though the events themselves are absolute within spacetime, the observers only have a partial view into spacetime. Another absolute feature of spacetime is the spacetime interval, which is a measure of distance between events in spacetime. Just like we're familiar with measures of distance between points in 3-dimensional space, a spacetime interval is a measure of distance in 4-dimensional spacetime. The spacetime interval is also real and absolute, and it is found to be the same between observers across all reference frames. The spacetime interval is more real than what any observer can measure about space and time separately. We can compute the spacetime interval from an observer's measurements of space and time separation between two events as the spacetime interval squared is equal to the time separation squared minus the space separation squared. Events and spacetime intervals are enough to completely define all locations within spacetime, regardless of the reference frames of the observers.